Hello, everyone. TGIF. Unless it's already Saturday where you are, maybe, or still Thursday night. But otherwise, then it's Friday is approaching. And we're really excited this weekend because it is the total lunar eclipse on Sunday night. So we're here to just start prepping you for that. Hi, Paul. How are you?
I'm very well, thank you, Paige. It's early evening here in the UK, and we got a live feed, I believe, from the UK. It's one of our test live feeds. But yeah, we're really looking kind of forward to this one. It's badly timed, this lunar eclipse for us over here in Europe, but perfectly timed for you guys over in the Americas, isn't it?
It is, but unfortunately, so I'm on the East Coast, and so for us, it's going to be around 10 p.m. Eastern on Sunday night into like 2 a.m. ish Monday morning. But the problem is that we're expecting like a huge ice storm, at least in the Northeast, and
Mm.
so yeah, the one total solar eclipse we're going to be able to see, and I'm not actually going to be able to see it. I mean,
To, to,
thank goodness for
to,
Slooh.
yeah, total lunar as well. So
Yeah,
yeah, you're right. You
yeah.
said solar.
Oh, did I?
Yeah,
Oh,
that would be really cool. That would be really cool to see. But
TGIF.
this one. This exactly. This one's gonna be good, isn't it? I mean, Paige, this one is a little bit special. So it really is an eclipse, a lunar eclipse that people shouldn't miss, either in
Yeah.
Europe or actually anywhere in the world.
Right. It's the last one until May of 2021. So we're going to have to wait
Wow.
a little over 2 years to see another total lunar eclipse.
Yeah,
So you
and
don't
and
want to miss
it's
this one.
it's it's kind of even worse than that as well, because usually kind of in between time, you'd get a few partial lunar eclipses where, can still start to see some color. But in fact, there's a partial lunar eclipse in July of this year, but all of the other eclipses, we're going to talk about this, aren't we, later on, the types of eclipse and stuff. But
Mhm.
all of the eclipses between July 2019 and that total that you're talking about in May 21 are all penumbral eclipses, which are really difficult to see
Right.
with the naked eye, let alone with cameras and telescopes and stuff like that.
It also happens to be the first supermoon of the year, which means that the moon is going to be at its closest or near its closest position to Earth. And so we'll show you Sunday night, but we have a comparison of what a supermoon looks like when it's the closest to Earth versus a mini moon when it's the furthest. And so, because this is a supermoon, it's going to be just a bright, beautiful show. And it's the first of three supermoons this year. So the next two are in February and March. We
Now,
have three right in a row.
there's quite a lot of debate about supermoons, and I normally steam into this one heavily. When you say something super, I kind of think of it as being the best possible thing there can be. So when we say there are three supermoons in a row, there's this definition of a supermoon which enables that to happen. But to me, I I I will start a campaign. I'll start a petition for this page. I think there should only be a single supermoon every year. In other words, the biggest full moon of the entire year. And we should
Right.
change this definition to stop there being three consecutive. What's
Mhm.
so special? What's so super about that? Well, this first one this weekend is, under my definition, the supermoon. It is the biggest of the year.
Right.
So this is definitely the one not to miss. So you're going to join me in
The
that
most
campaign,
super.
Paige. The most
Okay.
super, the most super moon. Yeah,
Right. Right. And so the other thing for it to be a supermoon is that it needs to be a full moon. So that's the other thing that we have because it's a supermoon. It's a full moon. And because it's the full moon in January, it is also known as the wolf moon, which, if you
right.
tune in Sunday night, you'll hear a little bit from Helen Avery talking about what the wolf moon is and what its meaning was to our ancient astronomer ancestors.
Yeah. So
So what do
basically,
we
the
have
only
up on
real.
the screen right now? We
Oh yeah,
have
yeah.
a
Go on, Paige.
graphic showing the difference between a lunar eclipse and a solar eclipse. So I guess it's a good thing I made that mistake a few minutes ago because this leads right into it. They are two different things,
It
even though
wasn't a
both,
mistake. You said it deliberately, Paige, to line
yeah,
this up, didn't you?
right,
It was all
right.
deliberate. Yeah, yeah, yeah.
I feel like even though the total solar eclipse, the great North American total solar eclipse happened in 2017, I feel like it still like rolls off the tongue. I said it so many times, like
Yeah.
surrounding that
It
that
does.
moment. That,
It does. You think about an eclipse, and we were talking about that for a year, the
yeah,
transcontinental solar eclipse. So it kind of sticks, doesn't it?
yeah, yeah. Um, but yeah, so the two different kinds of eclipses, they both use the same bodies. We still need the sun, earth, and the moon for both of them. It's just that the Earth, moon, sun system, the configuration of the bodies is different. So for a solar eclipse, the moon moves in between the earth and the sun, as you can see on the bottom of this graphic, and the moon completely blocks the sun's light if it's a total solar eclipse, which is just due to the fact that the moon is about 400 times smaller than the sun is 400 times further away. And so this like chance ratio happens, which allows the moon to completely block the sun's light. And then, of course, if it doesn't fully block the sun's light, it's a partial solar eclipse. So the same thing happens for a lunar eclipse, except the moon is going behind the Earth. So the Earth is in between the moon and the sun, as you can see in the top part of this diagram. And so the moon moves into Earth's shadow and is eclipsed by the Earth. So we can watch from Earth as the moon disappears into our shadow and then reappears on the other side, disappears. Um, you'll be able to see it turn like red as it starts to enter the umbra phase.
So,
What
Paige,
is that red?
all of these things are called syzygies, aren't they? And we're going to be talking a little bit later about the other kind of syzygies. And syzygies are any alignment of three bodies when we talk about syzygies in astronomy. And we can
Mhm.
see there very clearly, each one of those is a syzygy. There are three celestial bodies lined up in a row. But you were talking there about the moon turning red, but that only happens, doesn't it, during this total lunar
Yes.
eclipse. So um, we're seeing two shadows there cast by the Earth. We've got this penumbral shadow and we've got the umbral shadow. Yeah, it is only during this total lunar eclipse that we see it red. Why is that? So can you explain to viewers, what this diagram's showing there?
Right. So all of the moonlight that we ever see from Earth is reflected moonlight from the sun. The sun is shining on the moon, and the light is reflected back to Earth off of the moon's surface because of its albedo. So when the moon is entering into Earth's shadow, we're just seeing a different version of the wavelengths of light coming off of the moon. So when we look at the moon on just a normal clear night, you're seeing basically white light, white reflected sunlight, which is all the colors. When the moon is entering into Earth's shadow like this, the light has to travel through more atmosphere to reach us. The light is bent on different paths. So the way that light reaches us, it comes in waves. We call these wavelengths of different color of light. So you have red all the way to indigo and violet. And when the longer wavelengths of light, the red light comes through, reflected off the moon's surface, that's what we see. So the sunlight is shining onto the moon's surface, and then the light is reflected back to Earth. But the light is bent coming through into our atmosphere. And so we see the longer wavelengths of light come through, which is why the moon looks red.
So during that total phase that we're going to see on Sunday, the moon actually isn't being illuminated directly by the sun at all, is it? All of the light that is reaching
Right,
it is being bent around or bent
right.
through Earth's atmosphere, and that's what's illuminating it. That's going to bring up something that's going to be quite good for us on Sunday if the Canary Islands Observatory is open, because our Canary 3 telescope, the moon, full moon especially, is usually too bright to image with that. But because this gets so much fainter, because it's not being illuminated directly by the sun, we should be able to use that telescope as well as the other telescopes as well. And we'll see some of our live feeds at some point during this, because we're testing. We're testing everything tonight. We're testing the studio. We're testing our broadcast. We're testing our knowledge. We're testing all of the systems. We're testing the telescopes, because there are a few telescopes that online now. And if viewers are watching at slooh.com on the Situation Room, have a look at the tabs below, because you'll be able to switch
Mhm.
between the Canary 1, Canary 2, and the Canary 4 telescopes. We don't usually use the very big telescopes like Canary 1 half-meter telescope and Canary 2 ultra-wide telescope, because it affects the following missions, because the moon is so bright it almost kind of burns. It leaves this kind of ghost image of the moon, which spoils some of the images and the image stream coming after that. But yeah, so this is quite a what's called a deep total lunar eclipse. So the moon is going quite deep into that dark umbral shadow. And the darker, or the deeper the lunar eclipse, the darker red colors we can see. So that's something to keep an eye open for viewers on Sunday night as well.
And you can see what that is if you're looking at the top part of the diagram, the lunar eclipse, where the moon is entering into the umbral shadow. So you can, if the moon is closer to the Earth, you can see it's going to go through that umbral shadow for longer, versus if the moon is further away from the Earth, it's going to have a shorter time in the umbral shadow. So that's the deep eclipse part that we're talking about.
So, Paige, if we're talking about our perspective, and that's what we're going to see on Sunday, but when we have a lunar eclipse, if you're an astronaut, uh, maybe a Chinese astronaut fairly soon, I think they're maybe going to be the first people to get there, aren't they? What would an astronaut standing on the moon see during a total lunar eclipse?
So we actually have a graphic for this we can pull up. There we go.
Ooh,
So
that's
the
pretty.
moon. So if you're an astronaut standing on the moon, I think this is so cool. You're actually going to see a solar eclipse, a total solar eclipse. Because remember, in order for us on the Earth to have a lunar eclipse, the look at the animation. That's what you would see. How beautiful is that? So if you're standing on the Earth, in order to have a lunar eclipse, right, the Earth is in between the moon and the sun. So if you're on the moon, you're going to have the Earth in between you and the sun, which is a solar eclipse. So the Earth moves in front of the sun, blocking the light, and so you're going to get that darkness. If you watched the total solar eclipse of 2017, you're going to get that darkness with the bright ring around the Earth, and you can see the different colors coming off of the side as the light is passing through Earth's atmosphere. So that's something interesting that we don't really have when we have a solar eclipse and the moon moves in front of the sun, because the moon doesn't have atmosphere. But as the Earth moves in front of the sun, you can see the visible spectrum of light being separated by the different layers of atmosphere that the sunlight has to go through.
That would
So
be
now I
so
really
cool,
want to go
wouldn't
to
it?
the moon. Yeah.
Exactly. That would be, and probably in your lifetime, probably not in mine, but people will witness this at some
Yeah.
point,
I'm sure there's
as
going to be
well as
some
witness.
Groupon for like a trip to the moon to
Exactly.
see a solar eclipse.
Hey, listen, Paige, before we go to a break, I wondered if the studio could pull up maybe the Canary 1/2 meter telescope view live stream at the moment, because it is astounding. These are high resolution images of the moon tonight. We're under. I've just been told that's the only one we haven't got, but maybe we'll see that a little bit later. But if you are watching at Slooh.com in the Situation Room, go down to that Canary 1/2 meter tab, and it will knock your socks off. The high resolution images of the moon tonight. So
It
that's
does
going to
look good.
bode
I'm
very
looking at it
well.
now.
Yeah, very well for Sunday night. So, Paige, I think we're
Yep.
going for a short break now, aren't we?
Yeah. Yep. We'll be
And
back
what are
in
we
just
going to talk
a
about?
little bit.
What are we going to be talking about afterwards, though?
So what we're going to talk about after is whether we can see similar events of these eclipses on other planets. And do other planets with moons have lunar eclipses? And what can we see from Earth? And have we seen any sort of eclipses in or shadow transits on other objects in our solar system from our telescopes? We have a lot of fun things
Yeah.
coming up. Oh,
It
and
is. We've got some great examples from Slooh members as well. So,
mhm.
okay. Well, we're going to take a very short break. So don't go anywhere, because we're going to be back with all of that, and we'll tell you more information about Sunday's total lunar eclipse show that you must not miss. Bye for now.
Welcome back, everyone. We had a short break, like we promised, very short. So we are here to finish off this little lunar eclipse prep that we had started for you. So we are going to bring back on Paul Cox, and we're going to talk now in this second half of our prep about whether we see events like this in the rest of the solar system. So do planets, other planets in the solar system, and what does that mean for exoplanets? Do they have eclipses, solar eclipses, lunar eclipses? What sort of components do they need for
Welcome
that to
back,
happen?
everyone.
Welcome back, Paul. We had a short break,
Hey,
like we
Paige.
promised, very
Sorry.
short.
Hi, Paige.
So we are here to finish off this little lunar eclipse
So
prep
why
that we
don't you
had started
we'll
for
start
you.
this off, Paul. Why
So
don't you
we
tell
are
us
going to
what we're
bring back
looking at
on
right
Paul
now? This is
Cox
our first
and
animations
from
from
a
a
Slooh
now in
telescope. This second half of our prep
Yeah,
about
so Slooh
whether we
members
see
will know that
events
I'm
like
a
this in the rest of the
long-time
solar system. So
Jupiter
do
fan, but
planets,
also
other
time-lapse
planets in the solar
animation
system,
fan
and what
because
does that mean
I
for
love
exoplanets? Do they
seeing kind
have
of celestial
eclipses, solar
mechanics
eclipses, lunar
in
eclipses?
operation,
What
and
sort of components do
this
they
is
need for
Welcome
that
kind
to
of
back,
happen?
everyone.
explaining a
Welcome back,
couple of things
Paul.
here.
We
So what we're
had a short
seeing
break,
here
like we promised,
is,
very
sorry,
short.
this is
So
from the
we are
Canary
here to finish off
2
this
time
little lunar
magnification
eclipse
So
prep
why
that we
don't
had
you
telescope of
started
we'll
for
Jupiter.
you.
start this off,
And
Paul.
So
Why
if
don't
you're
you
we are
tell
going
us
to
what
thinking
we're
bring
to
back
looking at
on
right
yourself
now,
Paul. This
Paul?
is our
hey,
first
something wrong with
We're
this
going to
animations from
talk
a
image,
Slooh
now in
telescope.
it
this
The
doesn't
second
look
half of our
round. Well,
prep
it's yellow.
about
So Slooh
whether we
members
see
will know
events
that I'm
like
an
this in the rest of the
long-time
solar system. So
Jupiter
do
fan. But what
planets,
we're really
other
looking at,
planets in
and
the
as the
solar
animation
system, and
goes
what
on,
does that mean
I
for
keep an eye open on the left because, first of all, you don't see anything. It's just black. And bang, there, you suddenly see a small white dot appear. Now, that small white dot is Jupiter's moon Io. And the reason why it suddenly appears is because before that time, it's been in Jupiter's shadow. So this page is where, there's this can get quite confusing. These syzygies, right? These
Mhm.
eclipses, these conjunctions, oppositions, transits, all manner of terms, kind of explaining the same kind of thing. But here in this diagram explains exactly what's going on in that particular time lapse. So there we can see Jupiter there. We're looking down on the Jovian system from the top. So we see Jupiter, we see half of it illuminated by the sun at the bottom. And Jupiter's shadow, of course, just like Earth's shadow on Sunday night, is going to be cast out into space. So what we were
Right.
seeing there when we couldn't see Io, Io was actually in Jupiter's shadow. So there was an eclipse. And then it emerges from that shadow. So we also, though, get a whole stack of other strange phenomena on Jupiter, especially. One of the things is that I always try and explain to Slooh members is how on earth do you know when those phenomena are going to occur? And if members go over to the Slooh discussion boards, they'll see a couple of articles and some downloads for some free software. And we've got a screen grab of that actually that we can show. And here it is. So all you have to do is set the location of where you are, and that's all over in the discussion boards as well. So we set the longitude and latitude of the Slooh observatories, both in Chile and in the Canary Islands. We set the date and time. And there you can see that it gives us a little box. It gives us diagrams, first of all, where we can see where the four Galilean satellites, the four Galilean moons, are at that particular time. But you can also see this little box down the bottom that says phenomena. And there you can see that it says it's got an occultation starts. That is when the moon actually passes behind Jupiter's disk itself. Then you've got eclipse start when it passes in to Jupiter's shadow, which is and can be usually a different time unless Jupiter is at opposition. And then you see that the occultation ends, so it comes out from behind Jupiter's shadow, but then there's a gap of time before it comes out of Jupiter's shadow when the eclipse actually finishes, when it ends. And this is just another little example, but kind of in reverse. So here we can see Io and its shadow passing, transiting across the front of Jupiter. So if you could stand on
Yep.
the surface of Jupiter, which you can't do, and you were in the path of that shadow, you would go into darkness and you'd see a solar eclipse. So, it's all pretty cool stuff, isn't it? There's a
Hmm.
lot of this stuff going on in our solar system, which I absolutely love.
We need to build some sort of flotation device so that when we can visit these gas giants, we can like float in the
Float on the
atmosphere.
clouds, that would be
Yeah.
good, but would you really wanna be in that terrible, terrible storm, the
Mm-mm.
biggest storm in the solar system? I think you'd need a pretty big boat
Most
for that one.
definitely
But
not.
but hey, listen, Paige, Jupiter's not the only place where these syzygies happen.
Right.
Mars's moons have some similar events as well, don't they?
Right. So Mars's moon. So the requirement for these syzygies and all the different versions of them to happen is that the object has a moon. So you need to have a planet, a moon, and a sun. You just need those three bodies. And so Mercury and Venus don't have moons, so they're out of the equation here. But all the rest of the planets in the solar system do. So, for example, Mars. And so we have an animation of Phobos transiting across the sun. If we pull that up, oh, there it is.
Well, this one's not an animation, so this one is 3 static shots. So unfortunately, that image has
Ah,
been
yeah.
squished a bit. So Mars is the kind of disk behind.
There we
If
go.
we can go back to that one, that no, this is another one actually. This is an annular eclipse. But if we can go back to the Mars one, because what we've got there is Phobos, which is, we think it's a captured asteroid, don't we, Paige? Which is why it's
Right.
itself is not round. It's kind of more jaggedy than that. But what we've got here is Phobos transiting across the face of Mars. So in this one, if you were standing on Mars, what would you be seeing here? A solar eclipse?
Right. So you would have the moon in between. If you're standing on Mars, if you're a Martian, you would have the moon in between you and the sun. So you would have a solar eclipse.
Actually, I got that wrong. What we're seeing in the background there is the solar eclipse itself, because that is the sun in the background. So this was taken,
So this
wasn't
is
it,
from
by,
Mars for
yeah, so it
curiosity.
was taken
Right.
by curiosity. Yeah. So so there we're seeing it now. This is where the terminology can get confusing, because this can be called either a transit of Phobos across the sun, or it could be called an annular eclipse. But you were talking at the beginning of the show that, we got this remarkable coincidence with Earth, that the moon is 400 times smaller than the sun, but the sun is 400 times further away than the moon. So that's where we get this almost perfect alignment. So they'd
Mhm.
never see a total solar eclipse, would they, on Mars?
No, no, you would need that perfect alignment or more for it to happen. And this is
Okay.
actually the conversation that Paul and I were having yesterday um, about what is a shadow transit versus an eclipse and how do we define the differences. And you know what I really like is that we're just calling them syzygies. Like, I like
Exactly.
that blanket statement. Set our-
Exactly. But if
yeah.
you were to call that last one that we saw an annular eclipse, then we do also get annular eclipses from Earth. And this is an animation, time lapse animation that I put together of one of the many ring of fire annular eclipses that we covered here at Slooh. And this annular eclipse, annular means ring, and this is where, in fact, you wouldn't see it this weekend. This is where the moon is furthest away from Earth. So it appears smaller. So it can't quite cover the entire disk of the sun. So you wouldn't get a total solar eclipse, but
Right.
you get this ring of fire. And we've done a number of those at Slooh over the years, and they do kind of look pretty cool. Oh, we got another one here. Oh, so this is a good one, I think, from 2012. Now look at this one, Paige.
Ah,
This was such a cool eclipse to watch. But once again, not a total solar eclipse. And anybody heard me banging on about the transcontinental solar eclipse? There is no comparison between this, which is an annular solar eclipse, ring of fire eclipse, and a total solar eclipse. No comparison whatsoever. You have to see in your lifetime
mm,
a total
yep.
solar eclipse. But Paige, it's not just, uh, Phobos and Mars and all those kind of things, and in our solar system that have these syzygy
Mhm.
events. It happens elsewhere, doesn't it, in the solar system, or maybe to other stars as well?
Absolutely, yeah. So again, all the ingredients that you need are a planet, a moon, and a sun. And so, for example, out in the distant solar system, well, planet, dwarf planet Pluto has its moon. Yeah, I know. Has its moon Charon, and now this is a unique situation because Charon is really large compared to Pluto.
Yeah.
That goes into the whole definition of a planet thing, which we're not going to get into, but it's about half the size of Pluto. And so the other interesting thing about this situation is that Charon, so a lot of the moons in the solar system, the sun's in the middle and the planets are orbiting and they orbit around the ecliptic plane. And then we have the moons, which also tend to sort of orbit around that same plane. But Charon is on a very tilted orbit in comparison to the sun. So Pluto does have eclipses, but they are like widely variable and you'll only have a few like per century. I think Charon and Pluto put each other into eclipse for like 6 days at a time or something. And
Wow.
then, yeah, you won't see one for
Because
hundreds of
the
years.
sun, the sun must be an absolute pinprick, in the
Yes,
sky from
right.
Pluto. But shall we have a quick look before we round up the show page? Shall we have a quick look at some of our live streams tonight because we
Definitely.
opened up specially? So let's take a quick look first of all at Canary 1.5 meter if we've got that, because if we have got the Canary Islands Observatory open. Um, no, we still don't have that one. So, okay, let's have a look at the Canary 2 ultra wide field. That'll be a good one to take a look at. And there we go. So we can see, Paige, here that it's not quite full. It's still got
Almost.
another
Yep.
couple of days to go, hasn't
Yep.
it?
2 days.
2 days. So, what we were doing tonight, and hopefully viewers have been looking at those tabs on the bottom, because I have been banging on about two of the other telescopes. We have got to tune one of those because it's still a little bit too bright tonight for it. But um, we will be showing using those telescopes on Sunday night. And we are going to have some pretty spectacular views there. But we've also got some other feeds as well. I don't know if the studio actually has got our test feed from the UK. Um, that would be pretty good if we've got that. Yes, please. So this is from Andrew Dumbleton. This is from the UK. You can see fairly typical
Yeah.
UK skies here. We've got some clouds here. Andrew
Love
Dumbleton,
it.
I introduced last week. He is our new operations manager. So welcome once again, Andrew. But Andrew's using this, our show tonight, just as a little bit of a test for his live stream. So Andrew and I are hoping to have live streams here from the UK, but we also have a live feed from Matt Francis down at the Prescott Observatory in
Mhm.
Arizona, long-time Slooh partner. Matt, we haven't seen him for ages, and he's actually got a pretty good weather forecast because, Paige, you were saying weather forecast over there in the USA
Yeah.
is not great for Sunday.
No, no, it's going to be really bad. Yeah, so this is fantastic. I'm so excited to have so many different feeds, and I love the cloud coverage coming from Andrew Doubleton's feed right now. I think we should
Yeah.
record this for our next Halloween show in October.
Well, I said to Andrew the other day when we were talking about we're running out of time here, but I actually think for lunar and solar streams like this, a bit of cloud actually adds a huge amount of depth and this kind of
Right. It reminds
3D
you how
feel.
live your feed is. We are
Does
in the moment
indeed.
watching this. All right.
Exactly.
Well,
So,
let's wrap up real quick. So
yeah.
we're going to be back in just 2 days' time, Sunday night at 10:30 p.m. Eastern. We are going to be back watching the total lunar eclipse with you, me and Paul, and we're going to have Helen Avery talking about what the wolf moon means and how our ancient astronomers understood lunar eclipses. And then we're also going to be joined by special guest Raquel Nuno, planetary scientist from UCLA. So you're not going to want to miss it. I hope we've answered some questions. If you have any more, post in our discussion boards and we'll prep them for Sunday night. Have a good weekend. See you soon.